Hi guys, today I'm making a video about probability rules. This is for the Chapter 5 test. This video will go over all 5 rules and I'll complete a couple of examples. So you'll need a piece of paper and a calculator so that way you can follow along. So let's start with just the rules. So there are 5 basic probability rules. The first 3 are pretty easy, and these are things that you would already know from just basic life. This says that the probability of an event A has to be somewhere between 0 and 1, and it could be 0 and it could be 1. So the probability that you're not going to have a test this week, how do I say that? The probability that you will have a test this week is 1. The probability you won't have a test is 0 because you are having a test this week. Hence the video. Okay, so number 2 says the probability of S. S means sample space. And a sample space is a listing of all the outcomes of that event or whatever is occurring. And that sample space, if you were to add up all the probabilities of that sample space, like rolling a die, if you were to add up all the probabilities, they have to add up to 1. This symbol right here, that means complement. Complement is just another fancy way of saying opposite. So the probability that A will not happen is 1 minus the probability it will happen. Okay? And these are the ones that are a little bit tougher. So let's go through these nice and slow. This says that the probability of A or B is the probability of A plus the probability of B minus the probability of A and B. So again, this is or union, and this symbol is and or intersect. And this is pretty special right here, that piece right there. What that piece is saying is you're going to add up A and B and you're going to subtract out what you've counted twice. Now, because we said that this is A plus B minus A and B, because you're counting it twice. Well, if two things are disjoint or mutually exclusive, they cannot occur at the same time. Okay, so that means that if A and B are both happening and they are mutually exclusive, they are disjoint, that means they can never occur at the same time. That's what equals 0 means. It means that they cannot, A and B do not happen at the same time. Okay, so that's the definition of disjoint. The definition for independent means that the probability of A and B is the probability of A times the probability of B. And the definition of independent means that A can occur and B can occur and one will not affect the other. That's why you're allowed to multiply. So the only reason I'm allowed to multiply is if they're independent. But most of the times they're not independent. And so you have to use a different formula called the conditional probability. So this symbol right here, this means if or given. And so what you're saying here is that A will occur if B has already occurred. A will occur given B already occurred. So conditional probability is saying that the conditions are A is going to happen only if B happened first. Okay? So those are the basic 5 probability rules. Let's go ahead and do a couple of examples. So at this point I would say take out a piece of paper, read the question, pause the video, and try to fill out this chart by yourself without my help, and then turn the video back on. Okay, the probability I will go to college is 58%. For you guys, it's higher because I want you to go to college. So the probability I will get a new car is 36%. The probability I will do both is 17%. All right, so let's take each variable one at a time. So the 2 events here are college and getting a new car. All right, so we're going to go to college, or we're not going to go to college. We're going to get a new car, or we're not going to get a new car. Right? So let's take this sentence by sentence. The probability I will go to college is 58%. So here's college. I could go to college here, and I can go to college here. So altogether, that's 58%. And then, so if this is 58%, the complement of 58, using the complement rule, this has to be 42. All right? So I'm done with sentence 1. The probability I will get a new car is 36%. So N means new car. So I could get a new car here, and I can get a new car here. So the probability I'll get a new car is 36. Well, using the complement rule, the complement of 36 is 64. Okay, so I'm done with the second sentence. The probability I will do both is 17%. Okay, so now this is where it gets a little confusing. Students have trouble figuring out, well, when do I multiply, when do I not multiply? This question is saying that both are occurring. Since both are occurring, we're talking and. So we're saying college and new car. So here's college, here's new car, so this is 17%. These two variables have to add up to 36. So this was all the ways of getting a new car. So this has to be 19. This is all the ways to go to college. So this has to be 41. There's a couple ways to do this one. This whole table has to add up to 1. This has to add up to 64. This has to add up to 42. So that means this number must be 23. Okay, so let's answer a couple questions. What's the probability I do not get a new car? Okay, so we have not, new car. So the way I would write that is new car, not. And the probability I don't get a new car is, oh, I forgot to write it on here. The probability of not getting a new car is 64. What's the probability of going to college or getting a new car? So let's write that down. College or new car. Okay, so that's going to be the probability of C plus the probability of N minus the probability of C and N. So that's going to be C plus N minus C and N. When I do that, I get 0.77. What's the probability of getting a new car given going to college? So here's the probability of a new car given college. Now when we do this, this is what has already happened. And this is what you're trying to solve. So this would be the intersection on top and what already happened on bottom. So let's go again. N and C is 71 and C, is 58. So the answer is 2931. Okay, so let's try a little bit more challenging example. Okay, here's another example with the table. Again, I would pause the video, try to fill out this chart here, and then I would go back and check your work. All right, so it says the probability people shower daily is 46%. So we know we're taking showers. And the probability, of the people who shower daily, 50% brush their teeth daily. Okay, so that's probably our second event. Brush teeth. And of the people who don't shower daily, 10% brush their teeth. All right, so let's put shower here, brushing your teeth here. All right, and let's start filling this out. Let's do sentence 1. The probability people shower daily is 46%. So here's showering. You take a shower here, you take a shower here. So altogether, that's 46. So that means the complement has to be 54. All right. Sorry, I'm getting a little messy. Okay, so now it says, oh, we're done with that. Of the people who shower daily, 50% brush their teeth daily. Okay, so here's all the people that shower daily. 46%. Let's say that was 46 people. Let's say there were 100 people. That means 46 people shower daily. Well, only half brush their teeth. So of that 46, only half of those people brush their teeth. So that's 46 times 50, which means that 23 people, or out of 100, 23% brush their teeth. Okay, this has to add up to 46, so this has to be 23. All right, so we're done with that one. Of the people who don't shower, 10% brush their teeth daily. So I know it sounds kind of weird, but there's 100 people, that means 54% don't shower. So 54 people don't shower. Of those 54 people, 10% don't brush their teeth. 10% of 54 is about 5.4 people. So using that same logic, we're taking 10% times the 54% of people that don't shower. That number comes out to 0.54. This has to add up to 54, so this is 0.486. The people that brush their teeth, that's 284. And the people that don't brush their teeth, that's 716. Okay, so now we're all done. So let's go answer some questions. All right, what's the probability of not brushing your teeth? All right, so we're not brushing teeth. So the probability we're brushing teeth not is, so brushing teeth not, 716. Okay? What's the probability someone showers daily or doesn't brush teeth? Gross. Probability that they shower or brush not is the probability they showered plus the probability that they didn't brush minus the probability of shower and brush not. Okay, so that is shower, brush not, minus shower and brush not. All right, not too bad. We got this. What's the probability of not showering, and not brushing? So shower not and brush not. This will be super easy now because your table's done. So shower not, brush not, 0.486. All right, and last one. Your friend comes to school smelling really good, so you know that that person showered. So you're positive he showered, and now you want to know, I wonder if they brushed their teeth. So we know that they showered. So what I'm going to do is I'm going to write that down right here because I know that happened first. I know they took a shower. What I'm trying to solve is going to go here. So I'm going to try to solve, did they brush their teeth? Okay, so that's the probability of brushing and taking a shower over taking a shower. So that's 0.23 over 0.46. So there's a 50% chance your friend brushed their teeth. Hopefully that they did, because that would not make a good day. So I hope that you are, oh, that should say brush. Just caught that. I hope that you are having a great afternoon, and I hope this video helps, and good luck on the upcoming test.